Hello and welcome to Codechef. In this video, we'll be discussing Java Encapsulation Part 1. We'll understand what encapsulation is, why it's important, and how access modifiers like public and private help us implement it. As you watch this lesson, make sure to practice alongside the video by trying out the code in the Codechef online compiler. The link for the same will be in the description below. So let's get started. Before we understand encapsulation, let's quickly visit classes and objects. A class is like a blueprint. An object is a real-world instance created from that blueprint. For example, a car class is the blueprint. An actual red car is an object. Objects have attributes like data and color and speed. Methods are actions like accelerate or brake. Now this brings us to an important concept called encapsulation. Encapsulation means bundling data and the methods that operate on that data inside a single class, and more importantly, protecting the data from direct, uncontrolled access. Why is encapsulation important? So imagine a car class with a variable called speed. If there is no encapsulation, any part of the program could do car.speed is equal to -100 or car.speed is equal to 10,000. This would create unrealistic or incorrect behavior. Encapsulation helps protect data, prevent accidental changes, making the program more reliable and maintainable. And in Java, we implement encapsulation using access modifiers. Access modifiers control who can access the variables and methods of a class. In this lesson, we'll focus on public and private access modifiers. Let's talk about public access modifiers. The public access modifier is the most open type of access. If a variable or method is declared as public, it can be accessed from anywhere in the program, from any class, even from different packages. In simple terms, public means open to everyone. Now let's look at an example to understand public access modifiers deeply. So here we have been given a car class with public access specifier for model, color and year. Then in our main method, a car object is being created. Its attributes are initialized and printed. This will demonstrate how easily you can access public members. Now let's look at the code for the same. Here we have car class, which defines a class named car. Then we have our details of the car. So here we have model that stores the model of the car, color and the year of manufacturing. Now we have my car is equal to new car, which creates a new object of the car class. Then we have all these details. We have a sedan car, a red and a 2023 model. Now our line of system.out.println will print our car model details, car color details and car year manufacturing details. So now let's try running this program. As you can see, the program prints the values stored in the public variables of the object. All these details were in our public class. Now let's talk about private access modifier. If the private access modifier is the most restrictive, if a variable is declared as private, it can only be accessed inside the same class. No other class can directly access it. This is the core idea of encapsulation, protecting the data from direct modification. Now let's look at another worked example. Here we have a simple counter class worked example to understand the practical use of a private access specifier. So here we have built a system to track down how many times a button is clicked. We ensure that the click count is only modified within the counter class to prevent accidental or malicious changes from elsewhere in this program. The count is made private so that it cannot be directly accessed or modified from outside counter class. Only the increment method is able to change its value. Now let's look at the code. So here we can see private int count, so a private variable that stores the count. It cannot be accessed directly from outside the class. Now we have public counter and this dot count. This is the constructor that initializes count to 0. Then we have public void increment this dot count plus plus. So this public method that increases the count by 1. Then we have public int get count return this dot count. This is the public method that returns the current value of the count. Now our main function begins here. Now we have counter my counter is equal to new counter, which creates a counter object. and now we have my counter dot increment, which calls the increment method twice. Again over here, now my counter dot count is equal to 10. This is the line which will cause a compile time error, and we have our print line which prints the count using the public getter. So now let's try running this program. Here we can see current count is equal to 2. The count was incremented twice, so the final value is 2. Now the commented line, my counter is equal to 10, would have caused a compile time error because count is private. Now let's summarize what we learned in this video. We learned what classes and objects are, the concept of encapsulation, why encapsulation is important, what access modifiers are, how the public modifier allows open access, and how the private modifier restricts access to protect data. Now that you understand the basics of encapsulation and access modifiers, try modifying the examples and running them in the Codechef online compiler. Practice is the best way to master these concepts. So keep practicing, keep coding, and I'll see you in the next video.